Hello everyone, welcome to my YouTube channel Akash Thing. So far we have learned a lot of things related to Docker. We have also implemented volume. We have implemented some of the Docker commands. We have implemented front end and back end together using reverse proxy Nginx. So today, what is special? So what we are going to do today is like we are going to create a multi-container employee management system. So again, we will not go very deep on the UI or front end. We'll just try to add employees details and see if it is getting reflected or not. And we'll try to add those employee details into the database as well. So last time in the volume session, I have used SQL database. You can refer that. So today I have tried to use PostgreSQL database so that you can get a different flavor. And similarly, you can change this as well in future. Then there is a backend as well, which is instead of Flask API, which we have used in the last video. Here I try to use fast instead of Flask, we have used Fast API. So that is the uniqueness. And then we have a reverse proxy set using this Nginx server. And also the front end, this time we have not used HTML, but we have developed a React based front end. So yeah, it's a lot of things. I think there are four services that we will be running through four different containers, and all these services will be interacting, and we'll see how this works, and we can build this complete system using just one command. Once we develop, once we understand the complete code and architecture, you will be able to build it using just a single command, and everything is running on the go. So I hope you are excited for this session. So with that, let's get started. Yeah. So as I have mentioned, the front end will be there, and then back end will be there, database will be there, and Nginx will be there. So here we have mentioned the port on which we will be hosting all of these, and we'll see them in the code as well. So this is how the project folder structure looks like. What all the important files that we need? First is like environment file to store all our uh, the keys and the database password username. So for those, and then docker-compose.yml, which you are already familiar to manage different containers or multiple Docker files. We need this. And then we have a README to just give a brief overview of about this project. And then there is backend folder, front-end folder, and Nginx folder. And in each one of them, we have Docker file to run that service or manage it. And then we have a backend, we have requirement and app file. So this app file will be where we will be performing all the fast, like we will be having the different modules for fast API access. And then configuration is nothing but kind of we will be loading our environment variables to access the database and perform the CRUD operations on top of it. And requirement is something that we need to install all so that we can run our backend smoothly. Similarly, for front end, since is our front end is in React, so we have defined these things, and this is again suggested by AI. So don't have much idea about front end, so I will tell it clearly that these all things is created by the AI. And then in Nginx, we have this default config where we will be uh, giving the port mapping and the proxy setting. So all these things are there. So we have total three Docker files, and we have one Docker compose YAML and .env file, which is very important for this project. So with that, let's see the architecture. So overall, the architecture looks something like this, that the user or the internet will try to access my application using this local host. And then this local host will be hosted or kind of hosted on Nginx on port 80. So this is what we will be able to see when we will access it from our local browser. And since there is a reverse proxy setup via this Nginx, so it will not expose like where my front end is running and where my back end is running. So this acts as a mediator in between the outside world. This is outside world or internet, and this is like internal assets that the organization or kind of project is having. So here we have front end. This is exposed to port 30, but this Nginx is like configuring it with respect to 80. So whatever the request that internet will be sending will be on coming on port 80, and then port 80 will check whether it's a front end call or a back end call or Postgres call, and based on that it will navigate to that particular port. Got it? Now let's go to the next section. So front end is again a single page UI we have developed where we will be showing the employee table as I already mentioned, and then we will be displaying all the like database related functionalities using this API. So as you can see here, the front end is hosted on port 3000, but it can fetch the data and make other API related calls using this 5000 port, which is where my backend is hosted. So you can see the port of this. And then backend is where like we can perform the CRUD operation, which is like create, read and update and delete the uh, records in the database. And we also have health check done here in the backend side. And also we have configured like avoid SQL injection. So we'll go through that as well. For Postgre, like mainly there is a single employee table with 7 columns. And we have also defined which is my primary key, which is our email ID. So it is going to be unique, and this is again hosted on this port number. Now Nginx, so this is hosted on port 80, and this will be navigating me to front end and back end on these ports. So what we are going to discuss here is like just a very high level overview, like what are the different operations or kind of requests that we are going to make, especially to the data ways. So that's where this unique like three, I think four unique requests we can see here. One is get, second is post, other is put and delete. So get, we have already discussed about get and post. So get is like when we just want to fetch any information. So at that time we see that. But post is used when we are sending some information via URL. So at that time post is trying to act as a security layer, and it combines everything inside a body and then encrypt it and then send the information, especially during login and something where we want to keep it secure. So put is mainly for updating the current data. So that's where we are going to like if we want to update the records of any particular employee using their ID, so we can do that. And then delete is like if we are looking to delete any information. So yeah, otherwise this get operation I think we are already familiar, just to fetch any information. And then we have SQL injection, which we already talked, and then course enable, so which let the kind of internal services connect to each other. Without this it can fail to connect. So now comes the Docker configuration. So we'll go in this through the code only. So let's directly jump to the code base now. So here is my code you can see here, and this is the same folder structure that we have seen in the presentation. So we can start with the backend, and this is like the most of the things are done here only, and this is our kind of main engine of this EMS system. So let's go through it. So first of all, we have the requirements where we are installing these three kind of packages. So fast API, because we are using fast API for all the requests that will be coming from the internet. So to handle that, and UVCon is just acting as a kind of server that will help in navigating those requests to my APIs from the internet. And this so I think this is more related to the database handling the PostgreSQL. So this is my requirement file, and then we have config file where I am importing the environment variables like the host name, the port name, where I will be hosting my database, and then the database name and a username. So this is what we are going to refer, especially employee DB and admin going forward. And here we also try to create the access URL for my database. So this is how like we try to have the URL whenever we are using PostgreSQL database. So you can see it's like just a combination of all of these above. Now we can check the environment variable here. So we have nothing but database name, user, and password. Yeah, that's all. So now let's go through the app.py file. I think this is the biggest file that we have. So here we can see all the libraries that we are using. So first is FastAPI, and we are importing the FastAPI and request. So request is again to request any kind of information from the internet using like get or post method, and then FastAPI is for like routing the kind of request. And then we have this coarse middleware, so just to help the backend and frontend interact. So that's where it will help me allow that connection. And then JSON response is nothing but JSONifying the output that we will be sending or reading, something like that. And then this one is mainly on the database connection setup, and this real cursor is nothing but parsing the output of the database as a dictionary. So, and then we are importing all the variables that we have defined in the config. So we have time also that we are importing. So these are the main libraries that we are importing. And then we are starting our fast API using this app. And then we are defining the coarse middleware that we have imported. So you can see like I have commented it so that anyone can read and understand it. So basically what it is saying that allow origin is a star. So star is like whatever the origins or whatever the like host name will be there, it will be allowed. So it should not restrict host name to just local host, but it can have any like point, like we have this 0.0.0.0. So any number can be here, right? So this is how our local host is, which is basically 127.0.0.1, but we can have any number for this. So this is what it's saying. And then method is again, we can have multiple methods like get, post, put. So we are using different methods. And header is like basically what kind of request header is coming. So we can see that in the inspect, whether it's a authorization related or content related. So yeah, for this only we defined it like this here. Now let's go to the DB connection. So just like the SQL database connection, similarly we have this DB connection. Just the module we are using different, but we are passing all the variables that is needed to build that connection. So once the connection is established to the PostgreSQL, we can also see this initiating the database. So first we build a connection. So here we are building that, and then we are creating cursor. So kind of like interpreted like connection is my call between, if there is one person calling, so phone line is my connection, and then the person who is speaking on that phone is the cursor. So something similar you can see, and using this cursor only he can like execute the different queries. So for here we are first creating the employee table if it does not exist, and then we have these following details here, like ID as my in, unique ID. So it will be primary key, and then name and email ID. Email ID is also unique, so it can also become a primary key, not a primary key, but as a like unique things. So there won't be two email ID with similar name. So that's similar value. So that's how we can refer it. And it is required column. So you can see it's required, and this is also required. So without this, we cannot add data into the tables. And then we have department, position, salary, and timestamp it will take by default. So again, we have defined the data types of these, and yeah, these are optional kind of columns. Then once we are done with that, so we are doing a commit. So what is happening, like whenever we run this execute, the changes are shown just to me. It's not saved permanently. So to save it permanently into the database, so that even if something crash or some problem happens, it should stay in the database, and that execution should happen in the database. That is where this commit is necessary to make it permanent. And then once the commit is done, we close the cursor and we close the connection also. So this is how we are going to use for any other operation of database as well. Here we were creating the table. So you can say like we are initiating the database. So that's where this is coming. And as I already explained in my last video also, that it is iterating over it 30 times. So it will try multiple times. If it fails, then it will try again after sleeping for a couple of seconds. And if it fails and doesn't create the table, so that means something is not working fine. So it will give that alert. Now we have multiple kind of functions here, you can see. So let me just give an overview for all of them. What are the important functions we have? So we have a get employee. So what it will do is like it will fetch the employee details that is there in the database. Then we have a create employee. This will help me in creating new employee based on the user, whatever the information user is inserting. And then we have update employee. So this is something that is trying to update the information of the current employee that is already there. And then we can delete any employee based on the ID. So these are the important functionalities we have, and all of these are routed via API. You can see API employees or API health, like that. And by default, this init kind of DB and get DB connection. So these two will be called in most or all of them. So you can see now. Let's go through one by one. So since API employees is nothing but it's just fetching all the information from the database for this employee I call table. So this is where first it's trying to build the connection. Then it's initiating the cursor. So here it's initiating in a dictionary format because it want to render it as like row by row. So that's where it is doing that. And then it's fetching all the information using this command and ordering it with respect to ID. So basically sorting it, and then it's returning that. And by default, it will pass 200 as the internet code. So we will be able to see that. Now next function is my get employee. So here what will happen? It's again, let's see what is happening here. So it will fetch the employee information. So basically, based on the ID, it will try to first build the connection with my database, then build the cursor, and again this cursor will be kind of like dictionary format so that we can render through the columns. And then we are running this query. So this query is nothing but it's trying to select all the employees whose ID is matching with this. Okay. And this is where SQL injection things comes into picture. So you can see I've mentioned it here. So what happens is like uh, if we write this instead of this, if we write it something like, let me just do it here. Yeah. And here we can use instead of this. So if we would have written it like this, what will happen? The user can write something command like where ID is, let's say, so the user can give something like ID equal to 1 and drop table employee, something like this. So what will happen? It will combine all the query, right? So the query will become something like this because it is a simple concatenation. So first it will execute this query and then it will execute this query as well. And this will this like delete all my data from the employee table, which is not a good thing, right? So to avoid this, we are passing kind of this ampersand s so that our input should go into like uh, objects. One is like this, the text, and second is ID. So these two will not be combined together. So it will treat ID as a value, not as a query. So that's where it's important how we pass information or take user input to pass the information to avoid like SQL injection. Now we will fetch the one row. Of course, there will be just one row. So that's where we are using this fetch one function to fetch that first matching row. And then we'll close the cursor and also the connection, and it will return the employee. And if there is no data available, then it will say that employee not found, and it will give a status code error or something like 404. So with that, let's go to the next, uh, yeah, next kind of model. So where we are going to create employee. Yeah. So here you can see the kind of function that we are calling. It is get here, and here also it's get, but this time it's post. Post because we are fetching the information that the user is passing into the UI. So that's where this request will have all those information, and we are parsing it into JSON, and then we are getting it like storing it in data, and from data we are fetching all those details that the user will be giving. So what is happening here? First the like it's trying to build connection with database. Once connection is built, it sets the cursor ready so that it can execute the query. So here it's executing the insert query. So it's inserting the details that are passed on through the UI by the post method into the employees table, and we are using the same SQL injection like avoiding those scenario kind of query here. And then it is also using returning a star here. You can see here. So what it will do, whatever the record that it inserts, it also keep it like stored in the cursor, so we can fetch it directly. So here we are doing that only. So whatever record that it just wrote, it's also fetching it in the employee, and it is returning as well to see that what data got added. And then it's also committing in between that to make these changes permanent, and we it can get reflected in the database for everyone. Again, if this fails, then there is a rollback option, which will like if the transaction fails, what will it do is like it will start from scratch. It will uh, disconnect to the cursor and like connection, and it will give the error that email already exists, so we can't add it. So mainly that can be the reason, right? Because email is unique, and if you are adding inserting the data, then it will fail. And there is a safety side we have finally also, which will close the cursor and also close the connection, which is on the safer side. Now you might ask why we have await and asynchronize here. So you can see here, I think we have it, asynchronous and await. So we have used asynchronous because of this await. So await is nothing but since here is a JSON like request we are fetching from the request, so it will take some time, and there can be like on a real time basis on a production kind of system. We can see like there can be multiple users who will be hitting this API. So instead of waiting for parsing the information that the user has sent, so what it do, it like acts as a kind of so let me explain it with a example of a chef. So like let's say the task of chef is to prepare warm water. Okay, so he will start heating the water, and then he has to cut salad, he has to prepare meals, he has to prepare other dishes as well. So he will not wait for the water to get warm, right? He will just set a timer, and he will go and do all other tasks, and then he will come back once the timer is over, and then he will take the input that the like the warm water there, and he start using that. Meanwhile the other tasks are also completed. So that is a similar way here await and async is working. So what it is doing is like uh, it starts this task of just like parsing the request that user has sent, and meanwhile uh, it processes other request as well, whichever is coming on this API. It does not wait for it to complete it. So that way it can handle multiple requests. And once this task is completed, it can go through the other task as well. So that's where this asynchronous comes into picture. So especially in put and post, we are using this asynchronous function. Otherwise, we are just using the normal function. So now I think you have a better understanding of this create employee function. And then we have this update the employee information. So for this, we are also using the await function. And then as usual, we are building connection, defining the cursor, and then we are fetching the employee detail based on the ID that is there, like for which employee we want to update the information. And then if there is no information, it will say that employee not found. Otherwise, it will run this cursor will run this execution command, which will update the name or the email or whatever the information that needs to be there. So basically, it will fetch all of them and it will try to execute this. Once it's done, then again it will kind of record the output and try to display it that this is something that got updated, and will close the cursor connections and other connections. So this is how this update employee function is working. Hope it's clear. Then we have this delete employee. So again, we are passing the ID and we are using this delete request here. So what it will do is like it will execute this query delete from employee where ID is matching with the ID that is provided by the user. And after deleting, it is also counting the rows that whether it has decreased or not. So that way, it will try to kind of give a message. So if there is like no data deleted, then it will be 0, and in that case, it will not execute this. Well, it will say that employee not found. So this is kind of pre-check that it is doing in this function. And then there is a health function, which is basically checking whether the application is or API is running good or not. And before running everything, it first try to initialize the database and create the employee table. So this is all we have in the app.py file. Now let's just look into the Docker file. So so far you might be very familiar with this Docker file and you will be able to clearly understand it. First, we are uh, importing the image Python 3.11 version, Slim version from Docker Hub, and we are going to use this to create our Docker container and image. So we are creating it then directly here app, and we are copying the requirement files at first, and then we are installing all the requirements so that our app.py function can work properly. So we are copying rest of the files, and then we are exposing it to 5000. This is where we are doing the port mapping for this backend. After this is done, we are like triggering this command via the Docker. So what this will do is like UVCon will create a web server kind of thing. So it will act as like a kind of interactor between the internet and the APIs that we have. So this app is nothing but app.py file, and this app is nothing but the kind of information that kind of instance of this UVCon that will run. And then this host is nothing but we are declaring that it can take input from anywhere. And this port is nothing but we are defining like uh, where this backend services will be running or from where like everything will be served. So that is where this thing is. So let me explain it with the help of a simple, again, the kitchen example. So UVCon is acting as a head chef, you can say. And then this app or app.py, which we have here, is the kind of, you can say, the recipe that are there in the book. And then what this does, it gets all the request from this Nginx. So let me just decrease the font. Yeah. So from Nginx, it gets all the request like this order you have to cook, this order you have to make, and then this act as a chef and it starts cooking all of those food items or parsing all those requests. and then it looks into the app.py to understand how to prepare it, and based on that, it takes the action accordingly. So what this will do is like it allows the like any network, from any network, the thing can come in. That is where it is open. But Nginx will do what? It will see whether there is a 5000 port or whether the request is coming for this gate or not. Unless until the request is coming for this gate, then only it will tell UVCon to start cooking this. So that is how these things are interacting. So any port, no, any the network on the existing container can send this request. So it can come via Nginx or it can come via uh, curl command also. So possible. But based on this port number only, it will get navigated further. So yeah, hope you are able to understand the backend. So overall, what is happening here? So Nginx will send the request, then this Docker file will execute that request, and whatever the request will ask for, it will take that suggestion from the app.py file to complete that particular request. And this app file will require the password or some other information. For that, we have this config file. Yeah, so that's a simple explanation of backend. Then from front end, we have the React setup done. So packager.json is simply considered as requirement file for React application. So you can see the dependencies are mentioned here. Next, React and React DOM. Then we have Docker file, which is important. So to run the React, we are using Node Alpine here image. And here also we are creating a new directory, and then we are copying the package.json so that we can start the installation. This is the installation command for React. And then we are copying rest of the files into this directory and then exposing this front end to 3000 port. And then this is the command that we are running to start the front end, basically on this port number. Next, we have the Nginx. So let's go to Nginx. Here we have the Docker file and the default connection configuration file. So let's go through the Docker file. So again, for Docker file, we are using Nginx Alpine image, and we can select any image related to Nginx, the different versions. And then we are removing the existing default.config file, which stay at this folder in the Docker desktop or like Linux engine that is running in the background. And then we are creating our own default configuration for the reforce proxy thing at this same path. So we are just copying it. And then we are exposing it to 80 port. So this is what will the internet or the local host, like I will be running in my local. So I will be able to access or see. And then this will run by default. Uh, So even if we don't define it, it will automatically execute this command because it's already mentioned in the Nginx. But just to help you understand this, so again, we can take example of the kitchen. So what happens is like, let's say we have a baker, and this is like how the shop or the bakery is. So here we have the front desk where the customer enters from here. Now, this is the kitchen area or the baking area. So if this baker comes here for baking the stuff because he is alone, so what happens is like this piece stay becomes empty. And then if the customer or the head of the shop comes here and see that this is empty, no one is here. So what it does is like it closes this shop and go. So this is similar thing happening here. So whenever this Nginx runs, it runs in the background, and if the Docker finds that nothing is there in the foreground, so it tries to turn off the container. So we don't want that container to go off. So that's where we try to do what? We assign this baker the task that you stay at the front end and someone else will handle the bakery thing. So every time he will be here, he won't go off. And then the customer will not or the owner will not shut down the shop. So yeah, that's a simple explanation I can give. So with that, I think we are good with all the three services. So let's directly go into the Docker Compose file, which is very important, where we have defined all our services. And let's try to go through one by one. So here we have already, like we also mentioned this version thing. Version is nothing but it will try to get all the rules and the latest kind of functionalities that we can have in the Docker Compose YAML file. So that's where we are using 3.8. We have a previous version also where like some services or some of these things are not supported, like this condition kind of scenario that we have here, I think. Yeah. So this particular thing, condition. So it was not supported in the earlier version. So that's why we are using this 3.8. Now let's go through it one by one through all the services. So we have mainly four services. You can see DB services, backend services, frontend services, and the Nginx services. And then we also define volume and networks. So why this volume and network are needed? Volume is because we are having a persistent memory so that even if the container is removed, still we can have the data in the database. So that is very important because it is possible that we may not be running the container all the time, but we have the PostgreSQL database which we want to use. So whenever the container again comes back up, we should be able to fetch back those tables or the details that we had created. And then network is nothing but this acts as a kind of a hallway. So kind of bridge between all these services. So if this like once you enter the hotel, you enter through the road and you comes into the hotel, you reaches the kind of receptionist. So receptionist is here like Nginx. This Nginx will try to guide you to what service you want to avail. Like you want to go to a restaurant inside the hotel, or you want to go to your room, or you want to go to cleaning. So based on that, it will navigate you accordingly. But to go to that place, you have to go through the hallway that is there internal to the hotel. Like no one from the outside directly come there. So first they have to come inside, and then only from inside they can go into the hallway to that destination. So that's where this EMS network is. So if we define a different network for different services, then all of them will not be able to interact. So this is important thing. And if we want to secure, let's say database, so we will have a different network for database, and we'll try to give access to only those services where we want to expose that network access. So kind of securing it. So now let's try to understand what is DV or how the DV kind of is defined here. So we don't have a Docker file, so we are directly initiating it here. So first we are writing the image name from which we will be creating this Postgres SQL database. So we are using this 16 Alpine version, and then we are creating the container name through which this will be hosted. And we have this restart functionality. So whenever the container will stop due to some reason or crashes, then it will automatically restart. And then we are also passing the environment variables that will be needed. And here is the port number to which will be exposed. And then here is the path to the volume where this database will be stored. And this is a command I got from the AI that through which it can test whether the health is okay or not for this database, because other application like backend will be depending on it. So that's why we need to check the health status. Now coming to the backend services, the backend. So here we already have data Docker file. So we are just building the Docker image, and then we have this container name as well. which we can check once the container is built. And then this stop condition is also there, that whenever it's a stop, it can restart automatically. Then since in backend we will be trying to use the different functionality of the database, that's why we are having these things here, and we are also passing the database port so that it can understand where this database is. And then this is the port of the backend, and since it's dependent on database, so it will check the condition whether it's healthy or not, and then only it will start this container. And then this is the network which we already talked about. Now coming to the next service, which is my front end. So it's quite similar to what we have in the backend. So first we try to build the Docker file. Using the Docker file, we build the image, and then we have the container name, and this restart condition is there, and this is the port mapping, and it depends on the backend only, and this is the network through which it will be talking. Similarly for Nginx, this is the Docker file which will be run to like create the image and start the container with this name, and restart condition is again here, and this is the port uh, where this Nginx will be listening from the internet, and it depends on both front end and back end. Unless and until both are running, it will not start. And then we have this network thing also for this. So yeah, so far I think it's clear. So let's go into the demo, try to run the demo. Just trigger the Docker. So we can use this docker compose dash d, as well as we can use this build. So this build is better because it will try to check whatever the changes that is there in the Docker file and Docker compose. And based on that, it will update the existing image as well. So that's where it's preferred. So let's execute this. I think I wrote the wrong command. Docker compose up and then build. Yeah, so you can see it started building the image. So it will take a couple of seconds, and then the image will be populated here. And once this Postgre image will be imported, we can see the other images it will also try to make, which won't take much time. This is the heaviest image it's making. Once the images are like imported from the Docker Hub, it tries to build that image inside my desktop, Docker desktop application. And then it will also try to check the condition that I have defined in the Docker file, whether others images are available and whether they are running properly or not, like the front end, back end, and then Nginx. And based on that, it will start all the services. So with just this single command, we are able to uh, trigger all the services, whether it's front end, back end, and Nginx, as well as the database services. So we can also try to check like how to for now let's see uh, the database that it has created. So in the volume section, we can go and check that. Right now there is nothing. So right now it's just creating it. So you can see it has created the Postgres, and then this is the Nginx service that it has created. You can check it here. So you can see all the commands that we have listed are here. Similarly for Postgres also. So this is the like automatically uh, finding all the commands from the image, and then by default it's running those. For the backend also, you can see these commands we have written, and this is same, it's running. And sooner we will have the front end as well. Now let's see the container. So right now there is no container. So they will also start coming. Still loading. Let's wait for a couple of seconds, and then we will have it. Yeah, I think now we have the front end as well. You can see the front end. Now let's go to the container. So you can see all the containers started at first it has started the database, then the backend, and then the front end, because that was the dependency. And then finally the Nginx also came. Now uh, we can access the front end from this port as well. So you can see uh, if we can access this, right? And we can also access it from here. But since all our internet traffic will be coming from this, so user will not have access to this one. So let's not use this, and we will be using this. Now let's try to see the volume if it has created. You can see the volume also got created here. Let's try to now insert some. Let me enter my data here, and then department, you can say manufacturing, and then kind of consultant, salary maybe 150. Now add employee. Once I do this, you can see employee got added. So let's add couple of more details like Deepak, and then a@g.com, and then in engineering, and then engineer 50,000. Okay, now we have this, and then let's try to, yeah. So let me go to exe and run psql dash u username. Let's try to see admin. Let's try to pass this, and then dash employee db. You can see I have access to the database. Now let's try to sort tables. Okay, it's not recognizing. Maybe select star from employee. Okay, maybe let me check the table name that we have defined. Here we can check that in the initiation. So the table name is employees. So you can see there are two records, and also the timestamp is stored. So all the 7 details are here. Now let's try to check the other functionalities as well. Let's try to edit this. So let me change the department to uh, functional, and then the email to deepak.j@gmail.com, and salary fine. So let's save the changes. You can see the updated details. And now let's try to fetch it from here again. So can you see the change? Yeah. So this functionality is also working. Let's try to delete one of it. Let's delete default. You can see. Now let's try to check it again. You can see it's deleted from the database. So I think these were the main functionalities that we wanted to see. So all of them are working fine. So now let's try to bring down the Docker. Basically, let's try to like bring down all the containers. So for that, we already learned this command. That is, first let's detach it. Again, like before that, let's try to check the what you can say, the logs. So here I have kept all those commands to check the logs. So where is that? This one. So let's also check the network. Mm, let's detach it, and then let's check the network. So here you can see all the network. So this is the bridge network on which we have created, right? And then volume, let's check. Does not take care. So it will give me the list of all the volumes that we have created. So this is the only volume which we have created. And then let's check the logs front end. and database logs. Let's see if you see anything. You can see all the responses here like 404, 404. Let's try to check the logs for the employee database. See what is there. So you can see these are the logs we have performed. So table, select a star, Nginx logs we can also check. So this way we can check the logs for the different tables, different container that is running. Now we can check all the containers that's running. Again, we have already used these commands, but yeah, just to show it again. So you can see all the containers here. And on the port number where it's running, all those are mentioned here. And for how long it is up, and maybe the size as well we can see. Rest of the things are working fine, and we are able to basically run multi containers together, and they are also able to interact, and we are able to work with it. Now let's try to bring down the container. So we have this command here, docker compose down. We just run the same command. So this will remove all the containers. Well, the image will stay. So here you can see, and the image stays, and even the volume is staying. So if we restart the container again, up and dash T, so you can see all the containers are started. And if we refresh this, we will be seeing the data that we had stored. So this is how like the volume things work. It stores the data permanently unless and until we like remove that manually using this command. So we have this command dash v. This will remove my volume. So you can see it will remove the container, and it will also remove the network and the volume. So now if you try to check, the containers are gone, volume are also gone. Only the image is here. So if we try to again bring up the container, you will not see that data. So the container are up. Let's try to refresh. You can see the data is gone. So I think this is uh, meant to be we have like this. So it's working fine. So I think this was all I wanted to show. So let's go through what all things or how all the things were connected or how it flowed. So basically, we opened the browser, and that browser navigated me to the Nginx, and this Nginx navigated me to frontend, and frontend navigated me to the frontend APIs that are there, which further navigated me to the backend. Backend connected with me database, and then the full circle completes. So that's how it worked. So for the page load, this is how it worked. And for the employee additional information, we like first added the information using the form that we saw, and then we posted it. So using the post request, the fast API was able to retrieve it, and then we JSON file like read that JSON data, and the backend validated that data and then inserted it or whatever the request was there based on that. It did that, and then it gave me the record that was performed and also the kind of code, and that's how like table also got updated in the backend, and it also shown me in the front end. So this is how like overall the application was working. And yeah, so what are the key takeaways? So again, like we have seen how the docker is working. Then we have also seen the docker compose. We have also talked about networking, how we can try to do reverse proxy, how we can set the server, how we can define a certain port ID for a certain service. So all those things. And then we have also talked about volume concept, which is very useful for defining any new database. So this way we don't have to depend on any external database. We can host our own database, and we can add additional security as well. We also learned about SQL injection, one of the way, and then the commands, of course, to build the database, and then health checkup. So I think this was a lot of learning. I know the video went a little long, but yeah, since I wanted to cover it all, so yeah. Now we have everything up. So just hit one command, docker compose up build, and all the services will be up on this local host. So yeah, we'll learn more about this. We will try to make this project deploy in cloud, and in future we can do a lot of things. We can also try to see how we can manage a huge amount of concurrent requests from the users. But for now, I think this is all I wanted to share. Thank you, everyone, and like, subscribe, and share your feedback in the comment. Thank you. Bye.